All right. Thanks for joining, everyone. Good to see some familiar faces there. Some people I haven't seen for a long time. Hello, Duncan. I guess we'll get started. I'm just going to share my screen, which in theory is going to work. If you don't see a screen share, please shout in the chat and I will try and do something about that. I've changed my tech setup a little bit this week, so I'm not 100% sure whether everything is working as intended, but hopefully you should see a title screen there. If not, please do shout in the chat. So, morning. We're talking today about architecture for security on AWS. So if you're expecting a different webinar, then you should probably be in a different place. Maybe sign out and go and do something else. Who am I? I guess some of you know me already. For those of you who don't, my name's Jon Topper. I'm the founder and the CTO of the Scale Factory. I do all of the running of things. I've worked in hosting and infrastructure for about 20 years, initially in the ISP industry and then through the startup world. And so hopefully you'll be willing to trust that I know what I'm talking about in this range of topics. My interests in particular are infrastructure and AWS, and I guess previously DevOps. I guess we still do DevOps. It's a bit more evenly distributed now as a practice, so I don't really call it out specifically anymore. And also, if you're the type of person who trusts bits of paper, I've got a couple of AWS certifications under my belt that hopefully demonstrates that I kind of know what I'm talking about in terms of AWS architecture. So details for today. Do feel free to ask questions through the session. There's a Q&A feature in Zoom. If you look at the bottom of your Zoom window, you'll see a Q&A button. If you hit that, another window will pop up. You can type your question in there. I can see those questions on my screen down there, and I'll try and answer them in line as we go. If I think I have slides later or a more relevant time to cover that topic, then I'll possibly hold on the question until later, or maybe come to it at the end. But do feel free to ask for clarification if something isn't clear. I'm recording this, so and I'll distribute the link to the video after the session once it's transcoded and I've cut out the 10 minutes at the beginning with a timer on it. And I will make the slides available as well, so don't feel like you need to take screenshots or anything like that. I will make all the materials available to you so that you can consume them at your leisure later on. This webinar is going to take about 90 minutes of your time. I'm going to be talking through more or less all of that, which is a bit of a challenge. So you will get a chance to ask some questions at the end as well, but do be prepared to listen for 90 minutes. If you need to leave early, then that's cool. Obviously the video is going to be available. I just want to set some expectations. Most webinars are about sort of an hour and they tend to be quite fluffy sales things. I like to talk for a bit longer than that and cover more technical details, so do expect that this is going to be a fairly technical dive. It skims across the surface really of a lot of the AWS platform, so we don't get really deep into the details, but we do talk quite technically for most of this, so please do set your expectations accordingly. So who are the Scale Factory? We are an AWS consulting partner at the advanced tier. We recently were awarded a competency designation for our work with the SaaS industry. We have also been involved in a program called Well Architected for a couple of years, which I'll talk about in a sec. And we recently qualified as an immersion day partner, so we can run immersion days for you and your team on a number of topics. If you'd like to know a bit more about that, you can let me know after the session. I'll hook you up with some details. We are an HMG Cloud supplier, so you can buy our services through the G Cloud framework if you're a public sector customer. We're also a Kubernetes certified service provider with a lot of the team certified in Kubernetes as well. So if you've got Kubernetes shaped problems, and if you're using Kubernetes, you definitely do, then you can hit us up for some help with those. We like to put people first as a business, and so this is the team. Lots of smiling faces. There are 20 of us as of today. and most of that team are AWS using consultants. We're pretty lean on administrative and other overhead. We are almost entirely a technical team, and we'd love to work with you if we have the opportunity. We have worked with a number of clients across a range of market sectors, so you'll recognize names like Expedia and ITV at the top there, and maybe some less familiar names down the bottom. The businesses here are all different shapes and sizes. We've worked also in lots of different industry sectors, so we're quite comfortable in, for example, compliance industries like pharmaceuticals and fintech, as well as the slightly less compliance-oriented businesses around e-commerce, media delivery, that sort of thing. So pretty broad range of experience. I mentioned well-architected previously. We are a well-architected partner. In fact, by total number of reviews, we are one of the leading well-architected partners worldwide. And the well-architected framework is it's a set of white papers and a set of review questions that ask good questions about how you've built your infrastructure and offer advice about how to make improvements. You can book a well-architected review with us. One of my team will spend half a day with you and your team, and we're looking at various aspects of your platform. There's about 60 questions in the base content. It's a really good way to get an outside perspective on whether or not your platform is doing the right things. Whether there are things that you've missed, whether there are things that you can improve. There's also funding available from AWS for supporting changes to workloads following a well-architected review. So a lot of the time, the work that we can do with you is at least part funded by AWS, which is a great opportunity. So do get in touch afterwards if you'd like some more information about that. Well-architected covers 5 pillars. They variously are security, reliability, performance, cost, and operations. Obviously, we're talking today about security, so most of what we're talking about lives in the security pillar. I'm going to be using some of the language that well-architected uses in this context because I think it's sort of useful to tie all this stuff together. And hopefully that will be useful to you. You can go and find the well-architected white papers fairly easily with a Google search if you are interested in diving in a bit more detail into that topic. So the agenda today, we're going to talk a bit about who is responsible for security. We'll talk about leveraging the AWS platform and the various solutions that AWS provides for that. We'll talk about the 5 general areas of security that AWS can cover with you. And we'll talk about well-architected a bit more as well later on. And then there'll be a session for Q&A. As I say, if you have questions that you want to ask, use the Q&A button at the bottom of the screen. I'm going to be paying less attention to the chat and more attention to the Q&A window if you have questions. I'm hoping today that you'll have something to take away to either think about or to try out. If you go away with a much better idea of what security products exist within the AWS landscape, I think I'll have done my job today. If you go away sort of slightly scared that you're not doing a good job on all of those things, then that's not unusual. And those are things that we can help with as well. So we asked the first question: who's responsible for security in your organization? Is it the CEO? Is it the CIO? Where does that responsibility live? And really, I think that the main thing I would say is that you're responsible for security. It doesn't matter who you are in your business. Security is something that you should be thinking about, and really, it's something that everybody should be thinking about. Werner Vogels, who's the CTO at Amazon.com, talks about security as job zero. It's like the first thing you need to get right, really. And considering that, it is surprising how many organizations don't really give due consideration to it. And it's possible that you're one of those organizations. You should probably ask yourself that question. So when we're talking about architecture for security, why architecture? Well, the word architecture implies a certain level of upfront design and planning. I think it's important to understand that it is easier to build security into a design of an infrastructure than to try and add that later on. And I'm going to be talking about the AWS components that are available to think about when you're looking at that sort of landscape, so that you can think about designing your security posture into your platform from early on. You can add security later. I don't want to sort of scare you into thinking that it's not possible to secure an existing infrastructure, but it's often more time consuming and costly. It takes more effort to do that. The State of DevOps report is something that I like to reference in quite a lot of my talks. The organization is called DORA, the DevOps Research and Assessment, I think, organization, now owned by Google. They've run a review of DevOps practice over the last 6 or so years, maybe 7 this year, and present findings from that report with decent statistical analysis. It's really the only empirical data collection that we do in the DevOps part of the industry. And so, although I'm given to understand that the statistics has its flaws, statistical methods have their flaws. There's a lot of value in that data. So the report surveys operations teams and groups them into high, low and elite performers, and we're looking at metrics like deployment frequency and mean time to recovery and defect rate, and tying those metrics back to particular behaviors. And the report found that the elite performer group typically builds security in. It's a correlated practice. So people who are thinking about security as part of the underlying fabric of what they're doing tend to perform better than those that don't. And elite performers can conduct security reviews and complete changes in just days, whereas the lower performers can take weeks to do that. So I think the stats and the data bears out that we should be thinking about this stuff up front as well. So our way, the way that we look at this as the Scale Factory is we like to put people first. So on average, the security approach needs to make people's lives easier and not harder, right? The people who are customers of your platform are people, your operations team are people, your developers are all people. And so we should be thinking about a person-centric approach when we're designing this stuff. We also think that you should be matching a security solution to the workload. I think a lot of places or a lot of engineers will think of security as an absolute, and really security is context dependent. And so there's no point in building a sort of military grade security solution for your Twitter for Pets application, because that's not a good fit. So bearing the context in mind is important, and that's one of the things that we try and do as we work with customers. I think it's important to leverage the AWS platform. Like, I don't like the word leverage as it's typically used in business, but this is, I think, the legitimate use case for it, which is leveraging is putting a small amount of effort in and getting a larger result out. And I think using the AWS platform, leveraging the features of it will get you further than not doing so. We also believe it's important to automate things. We're from the DevOps world, and so automation was really one of the things that we were doing very early on. And so almost everything that we do is related to automation in some fashion. And iteration is important as well. So I think it's important to recognize that change is pretty inevitable. Things are always changing, and so putting together a solution that you can modify over time and iterate is much more important than sort of getting it right from day one, pretty much. So let's talk about leveraging the platform. I mean, I think the first thing to say about using the platform is to stop worrying about vendor lock-in. I think there's a lot of FUD floating around about whether or not you should be beholden to a particular cloud vendor. And my view is that vendor lock-in, broadly speaking, and the idea of cloud agnosticism is sort of bullshit. You are going to be as soon as you touch anything on any cloud platform, you're going to be hitting aspects of sort of specificity to that platform. So as soon as you start using AWS, you're going to be working with IAM, which is the identity and access management tooling. That's very AWS specific. The other platforms have their own ideas about what that is, but you can't stay away from using IAM, and so you've immediately hit something that is vendor specific. And if you're not adopting vendor tools and services from the cloud platform, you essentially making life harder for yourself, because you're having to build functionality yourself rather than using similar functionality that's been provided by the cloud vendor. So really, stop worrying about vendor lock-in. If you're going to be on the AWS platform, you should be using the components of it, is my view. And of course, by doing that, you're reducing the number of vendors. And if you reduce the number of vendors you're working with, then you've reduced your complexity and therefore your risk. And I want to present an argument for this on the in a sort of format of a Wardley map. And those of you who don't know Wardley map, this format created by a guy called Simon Wardley, who worked with Ubuntu at one point, or Canonical, has done some work with the UK government, presents a way of visualizing value chain and the evolution of those components over time. And so if you look at this graph, at the top of the map is the customer, and we always have the customer there. There are lines then from the customer to the things that customer relies on. So this is a Wardley map for a database service. So the customer is using MySQL in this case. MySQL lives in the product part of the evolution axis, which means that it's something you can just download and use or buy. And in order to make MySQL work, that has some dependencies. So this is a highly available MySQL with clustering and config management and so forth. So we've bought, this is circa 2009. By the way, this is how we were building MySQL clusters in 2009. So the MySQL itself there relies on compute and storage, which is provided by a data center, and the data center provides power and networking, both of which are commodity because you can just plug in and get those. On the left over there is high availability scripting and monitoring. Both of those are in the custom part of the evolution axis, which means that we've had to take something and modify it in order to make it work. And over on the left there, config management lives in the Genesis part of the evolution axis, which means that we're writing that. We're using our own engineers' time to put that together. So in 2009, this is what you would be looking at if you were wanting to provide a MySQL service, a highly available MySQL service to your clients. And the way to think about this is that things on the left are more expensive ultimately because you are spending manpower on those things, right? You've got engineers cutting code, working on those things. Things on the right are less expensive because they become commoditized. So you can play off different vendors against each other for cost. And over time, generally speaking, you would expect things to move from the left of the graph to the right. If this is a commonly provided service, then it's going to become a commodity eventually. And so if we look at how that's evolved since 2009, this is the Wardley map for how your MySQL cluster would look in today. Right, there's just one blob, right? It's RDS Aurora. It's a commodity because you can buy it from your cloud vendor. And what I'm trying to express here, I guess, is that that using the tooling provided by the vendor in the cloud itself saves you from having to do a lot of heavy duty legwork yourselves. So your team, now that they can just buy an RDS Aurora rather than building all those HA scripts and the config management, can spend their time on things that are more beneficial to your business. So for example, building product or adding features to existing product, like you don't need as much manpower to do undifferentiated work, which allows you to move quicker and to save money ultimately, and to concentrate on the things that you are good at. And that's really the cloud argument, is to say, let's buy this from a vendor as is, because then we don't have to build all that ourselves, and we're probably not a database company. We're probably a social media company or an e-commerce company or something of that nature. In this case, RDS is actually serverless, so you don't have to worry about servers either. We'll have some more on that in a bit. So the AWS landscape is pretty broad. There's a lot of different product lines. I actually yesterday went through all of the products in each of these lists in order to construct some data set for how we work with customers. It's huge. There's loads and loads of these things. Like you probably are never going to use RoboMaker or the satellite services or so forth, but there are products for it there. And I think the message is that if you find yourself deploying software that you haven't written, you might be doing that wrong. It's a smell, I think, to be doing that, and you should probably reconsider. From a security perspective, the argument is also pretty clear. This is a diagram that Amazon called the shared responsibility model. Above the line, the sort of blue bits are the things that you as a customer are responsible for. So you are responsible for your data and your platform, your applications, all of your IAM configuration, so forth. You're also responsible for managing the operating system, networks, and firewall configuration if you're running EC2 instances. You're responsible for managing server-side encryption and so forth. Below the line are the things that Amazon are responsible for, or what I like to call the somebody else's problems, which is essentially running the compute, running the storage, running the database services, providing the networking, physically securing the regions. All of that sort of stuff is taken care of for you on the cloud. And so you're sort of transferring risk. You're sort of saying by consuming those services from the vendor, you're giving them some of your risk to take care of, but you do retain some of the risk. And so you've got to be aware of the things that you as a consumer are responsible for within that cloud. So let's look at the five different areas of security. I'm going to go through each one in turn, so I'm not going to read these five out. What I'm hoping to do is to cover each of these five, give you a flavour of what services are offered in the product to take care of those areas of security, and offer you some questions at the end of each section so that you can kind of self-assess where you are relative to good practice against those five areas. So first up, identity and access management. This is really foundational. I mentioned earlier, this is vendor specific. IAM is an Amazon specific service, and by necessity, I think. And really what IAM allows us to do is to identify principals, so users and groups and services and roles, and then attach policies to those principals. So in concept, it's fairly straightforward. So good things to do in terms of IAM. You have a root account when you create an Amazon account. It's associated with the email address that you create the account with. It's a super user. You shouldn't be using it, right? If you're today using your Amazon root account, then you are definitely doing the wrong thing. Really, you should be taking those credentials, locking them away somewhere in case of emergencies, and leaving them the hell alone. What you want to be doing is providing unique credentials per user, and to give those users least privilege policies. So making sure that they can't do more than they really need to do. You should also be using MFA, so multi-factor authentication. You've probably seen this if you use Google service, or maybe you've turned this on for Facebook or Twitter or Dropbox or GitHub or any of those things. If you use those services and you haven't enabled 2FA, then you should definitely think about it. MFA, 2FA are used interchangeably. We're basically talking about multi-factor authentication. So as well as the things that you know, so your username and your password, MFA or 2FA gives you something that you have, which is a security token, either a physical security token or a virtual one that you give after you've given your username and password in order to strengthen the idea of who you are to the system. And typically this means that if your passwords leak for some reason, someone's taken the post-it note off your monitor with it on or something like that, then the person who has your password doesn't also have the second factor, and so they can't get into your accounts. We generally find that this is not widely adopted when we do well-architected reviews. A lot of teams don't have this turned on, either because they don't know how to do it or they haven't got around to it yet. It's really easy to do. So if you are using AWS today and you have already created users per individual, great. If you haven't also turned MFA on, go and do that. Another thing you can do with IAM is to federate identity. And so if you are working in a corporate environment where there is an identity system like Active Directory containing information about your users, then you can essentially allow those users to obtain credentials to use the AWS platform using just the login credentials that they have for AD. So you have a single sign-on solution essentially. This diagram is I think a SAML representation of how you might manage that with an LDAP backing store. You can use basically any SAML service. There's OAuth options as well. And what essentially happens is that when you try and log into the console using and you want to use your federated credentials, you're bounced off to your portal to log in with your Active Directory credentials or whatever other service you're using. That bounces you back to the Amazon console with a token. The SAML assertion that you're given by that process, you can then hand off to a service in AWS and retrieve a set of STS credentials, which then you can use to talk to the console or the API or on the command line. And those credentials then get associated with a role. The role is informed by your policy configuration on the SAML side, and that role will dictate what permissions you have. So in the event that you are in an organization that has some kind of central identity service, it's really worth looking at this because it reduces the amount of legwork that you have to undertake when you have people joining the company or leaving the company. You can manage all that centrally as part of your identity management function, and that's all taken care of. We don't see a lot of this, although I think I'm seeing more of it over time, possibly because we're working with larger customers than we used to, I suppose. But if you're using AD or something like that, it's definitely worth looking into this. There's another part of IAM which is kind of interesting called AWS organizations. And this is a way of constructing relationships between multiple AWS accounts. So this is one of the areas that we've worked in a lot over the last couple of years with Well Architected. A lot of businesses are not using multiple AWS accounts. A lot of them are putting all of their workloads in a single account. And it's slightly dangerous because of blast radius and segregation and so forth. So we really recommend making an account layout and putting accounts into that. It's part of IAM because for every account you create, you can put it in a sort of in a tree hierarchy of organizational units. If you've used a directory service, you'll know what I'm talking about there. And each of those accounts or each of those OUs can have different policies attached to them through something called a service control policy. And the service control policy is used to reduce the scope of privileges within that account entirely. So even the root account under a particular even the root account of something with a service control policy on it will be limited by that service control policy. I've got a question here from, I think, Adrian. Is another advantage of federated login security-wise that you can revoke access from a centralized IT function rather than having IT access to one set of work-based systems and a separate system for IT? Yes, absolutely. It's I think that's what I mean by taking the legwork out of it. You're essentially giving the opportunity for IT people not to have to worry about user life cycle. Essentially, that's an important thing to consider. So the multiple account layout in AWS organizations, what we do here, there's actually something called landing zone and control tower that I'm going to talk about later, which is a more nuanced version of this or a more AWS version of this. But organizations, when we first started doing AWS Well Architected, those services were not available, and our recommendation was to create a single root account, maybe handle your billing through there, and use specific accounts for every type of workload that you're running. So you use an account to manage your single sign-on story. You'd use a separate security account with tighter security controls for managing the sort of security logging and security analytics I'm going to talk about a little bit later on, and then reduce access to that only to the people that should have access to security things, providing OUs then for services under which you have accounts for live and staging, and an OU for developers. So you have developer accounts, like one per individual working on your team, so that they can use a sandbox, but using that service control policy to limit the things they can start up. So only allowing T2 instance types, for example, for cost, or only allowing things to be started in Frankfurt or whatever. Sean's asking, for AWS organizations, are there any usability hacks to make multi-accounts easier to use? I will cover that when we get to the landing zone control tower stuff. So yes, ultimately there are, but I'll give you some details on that later on. So we've done a lot of work in this area, putting new accounts together, and this can be quite a lot of work if you are currently in an environment where all of your accounts, all of your services live in a single Amazon account. When we're talking about moving them between accounts, we are talking about redeploying your services, but often we do that as part of a work stream that is about improving automation and those sorts of things as well. So really the biggest, most important thing to take away from this session today is that your teams need to know IAM, right? IAM is everywhere. It touches everything that you'll use on the AWS platform. It's foundational and fundamental, and a lot of teams do a bad job of it. So you should really be encouraging your teams to learn this stuff properly. One thing that we see not done very well is the use of instance profiles. So this is a model in which an instance, or also actually a container or a Lambda, the approach there have different names, but an instance profile allows the instance to get access to a temporary set of IAM credentials, so that if your application needs to make API calls of the AWS platform, they can do that using credentials that are generated on the instance. You don't have to bake config files or bake credentials or usernames and passwords into config files. There is already a mechanism by which anything that runs compute in the Amazon environment can make API calls on your behalf. And we see this infrequently used, and it's really easy to get set up. So essentially, what you're looking at here is an application that needs to access an S3 bucket, and that S3 bucket contains application-specific things. What the application can do is make a query of a link local HTTP service, which will return a set of STS credentials that are then attached to a role that is related to the profile you've put on the machine. And that role you can attach an IAM policy to. So I can create a policy that says instances of type application are allowed to get objects from S3 from this bucket. And so when your application runs, if you don't give it any credentials to use AWS, it's going to go automatically to that link local service. It's going to pull those STS credentials back, and then it can use those to access S3. All of which without you baking any credentials into the config. It's all handled by the fabric of the platform. So please do look at that. If you're baking config files with AWS credentials, you can not do that, and you should not do that. When we talk about least privilege, we're talking about only providing the credentials or the privileges that a principal needs to act. So in that previous case, we're talking about an application that needs to access S3, and so we're creating a set of credentials that only allow it to use S3, right? And that's fairly basic stuff. But we do often find bad use of IAM policies, either sort of *:*, which is allow everybody to do everything, which is the sort of equivalent of all the Stack Overflow posts on PHP telling you to chmod 777 your uploads directory. Please don't do that either. And teams don't really work very hard to reduce the scope of the privileges that they're working with. This example here, please don't use that either. This was from the first non-AWS search page on Google for S3 policy, and this allows the holder of this policy is allowed to create S3 buckets, delete objects, put, get, and list anything on any S3 bucket in your account. And I think this blog post was this came from a blog post that was just about, I think, WordPress accessing S3 or something. This is terrible. This is way too much privilege for a WordPress instance to have. So do be critical of the IAM policies you're using. Do review them. One of the things that we do often following an AWS well-architected review with teams is to recommend a deeper security review. And often we find these privileges, and we can do some stuff with reporting on the logs from the platform to come up with a lower least privileged position for each of the policies that you have. So do be critical of your IAM policies. A lot of people are not critical enough. So just to reiterate, this is the message today. Right? If you're using AWS and you don't take anything else away from this session today, please teach your teams IAM properly, point them in the right direction, and help them learn how to do a good job of this stuff. We actually have a support and learning subscription as one of the products we offer, which is a monthly subscription that gives you access to my team for asking AWS questions throughout the day on a Slack channel. It's very, very human centric. We also run, as part of that, regular training courses, one of which is an IAM fundamentals course. In fact, even if you were not interested in subscribing to that support product, but you would like to teach your teams IAM properly, we can run a version of that course for you. It covers all of the basics and gives you a really good foundational knowledge of how this stuff works. So basically, your current use of IAM might need work. If you're logging in with a root account at all, like that, you definitely need to be changing that. If you have more than one identity for an individual, then that probably is a smell as well. You should only need one identity for an individual across all of your accounts. Don't use roles for compute. So if you don't use roles for your compute services, if you're not using those instance policies, then you can probably do some work there as well. If you're not enforcing MFA, then that's likely to bite you at some point. If you're hard coding secrets into your application configs, then that's a smell. You should not be doing that. You can use instance profiles and other tricks to avoid that. If you have IAM policies in your estate with a lot of asterisks in, that probably means they're too permissive. So you should probably tighten those up. And if you use a lot of the AWS managed policies, so there are a list that Amazon provide and maintain for you, they're actually pretty bad. There's a lot of wild carding in there. They're scoped a bit too broadly, and so you should definitely reconsider your use of those if you're currently using managed policies. And in particular, if you're in a sort of high compliance environment, you definitely don't want to be using those. You want to have those under your own control because they change over time as well. So the second area is detective controls. And these are tools that you'd use to identify potential threats or incidents. You use them to establish a baseline of what normal looks like, and then continually examine your system for anomalies. So as a first pass, your detective controls need you to be logging things. So if you're not using CloudWatch logs, for example, or CloudTrail, those are fairly easy to turn on, and you should definitely be turning on CloudTrail. I think CloudTrail runs by default and catches, I think, like 30 or 60 days of logs, but it doesn't log those in an S3 bucket. They're just transient. So if you want to keep long-term logs there of what API calls are being made against your AWS platform, you need to set up CloudTrail yourself and have those logs shipped into a bucket for future analytics. VPC flow logs, not a lot of people know about those. Those are traffic logs from your VPC, so internal traffic. And there are also DNS query logs, so your Route 53 DNS, and also the internal DNS that Amazon provides to you. You can log the results of that. And I think since I put this slide together, you can also log traffic from any network load balancers you've got set up for analysis. So do turn on the logging that exists. Make sure that you've got sensible retention policies. Most businesses don't need to keep all of their logs forever, but some compliant organizations might require you to retain those for 7 years or something. In the multi-account setup I showed you before, and the sort of organizations layout, the logging, we create a separate logging account and have all of the logs shipped into that account. Those S3 buckets then have policies set on them so that you can only append those logs and they can't be deleted. And so you have a fully non-repeatable logging setup there. Some users might be able to log in and read them. Some users might not be able to get at the logging account at all. No users can delete or modify the logs, and that's a really important compliance position. Sean's asking, is there tooling for visualizing VPC flow logs easily? I think easily is probably a word to define there. My understanding is that VPC flow logs are JSON format like everything else, and so you can poke at them with Athena, which is a SQL-like interface over the top of S3, and that will let you sort of dig around in those logs. I haven't done a lot with flow logs myself. If you would like to know a bit more about that, I can put one of the team in touch to talk in more detail about that. My job is spreadsheets, email, and webinars these days, so I don't necessarily have the experience to answer that, I'm afraid. Logging, making logs is one thing. Actually, using logs is another. There are various tools for analyzing all sorts of logs. So things like the Elk stack or vendor tooling like Datadog, for example, will let you sort of look at logging data and traverse it a little more in a slightly more user-friendly way. You can make queries with Athena, as I just mentioned, which is a way of using SQL-like interface over data held in S3. Really powerful. If you haven't used Athena, actually, it's worth a look. It's good for answering really quick questions about large data sets without having to import that data into any other tooling, which is great. You can also set up things with Kinesis streams. So Kinesis is a sort of streaming data analysis platform. You can push log data from your services straight into Kinesis. Kinesis can then run transforms and other sort of mogrification on those logs to generate reports or fire off events and so forth. So Kinesis is really powerful. If you think you're going to need to do a lot of stuff with logging, Kinesis is probably worth a look. If your data needs redacting, so if you're logging data that has potentially sensitive items in, Kinesis is probably worth looking at for that. You can have Kinesis redact fields or things that look like credit card numbers or other similar considerations on their way through the pipeline into sort of more permanent storage. So you can consider that. There's a lot of good stuff on about Kinesis on the Amazon website about these sorts of use cases. Another tool to look at is GuardDuty. GuardDuty is one of Amazon's machine learning-based services. Essentially, it's looking for anomalies, and it's looking for anomalies in your CloudTrail logs. So, as I said before, CloudTrail is a way of monitoring and logging everything that happens on the platform via the AWS APIs. And so, GuardDuty can sit and watch those and alarm on anything that looks unusual. When we first enabled this, we were working with a customer who was working for the banking sector. They were working with a bank in Asia, and one of their employees flew to Asia. I can't remember where now to go and talk to the bank, and he logged into their AWS infrastructure from there, and GuardDuty noticed that was weird. So people accessing from unusual places, that'll flag. Users making changes to IAM config who don't usually make IAM config changes, that flags up as well. There's a whole bunch of different kind of alarms, and it doesn't need a lot of tuning. It gets things pretty much right out of the box. And most of our clients who are using GuardDuty maybe get one or two alarms a week, and they're normal but unusual things. You can tune them to be more sensitive for certain types of activity and so forth. It's really quite cool, like as a sort of early warning system for weird things going on. Definitely worth enabling that, and it's a checkbox in the console or a single line of Terraform. Right? It's dead easy to turn on. One of the recent things that we saw was a customer who was running a VPN for their clients or for their users to connect to, and that VPN was configured to the VPN client was configured to route all traffic out of that VPN rather than just traffic for the customer's VPC, and that user was running Tor, the Onion Ring router, on their laptop. Presumably because they were surfing the dark web or buying contraband or something. And because that traffic then exited through their AWS infrastructure, GuardDuty noticed that and said, hey, you've got a Tor node on your network. You might want to have a look at that. So looks for things you wouldn't necessarily think to look for yourself, which is great. A couple of things that I haven't really looked at in loads of detail myself, and that are fairly new relative to when I put these slides together originally. AWS Security Hub, which provides you a comprehensive view of the high priority security alerts across all of your AWS accounts. So this is like a centralization play so that you can look at all of this stuff in one place, which is really useful if you're running a multi-account setup. And it aggregates, organizes, and prioritizes security alerts and other findings from various services. So if you're running a multi-account setup and you care about security, this is probably worth looking at. Likewise, Amazon Detective gives you a unified view of security events and provides you with visualizations of that information. Things like your CloudTrail logs and VPC logs are visualizable in that tool, and that in theory makes root cause analysis easier. Again, I haven't looked at that in any detail, so I can't really sort of vouch for it right now, but it sounds like it solves a real problem. And if you have a multi-account layout, you should probably be looking at Detective as well. So your controls in this area might need work. If you're not logging enough, if you're not logging anything, they definitely need work. If you're not logging enough, they might need some work. If you're not alerting on important log conditions, either using something like GuardDuty or maybe some of your own tooling, then you might not be getting value from those logs, and so that might need some work as well. If you've got a lot of alerts or notifications, or the alerts that you do have get ignored, then you probably need to do some work there as well, either on tuning the noisiness of those things or on making sure that your team is actually paying attention to those logs. And if you're not cleaning those up, then you won't necessarily get that value. And if you're only using logs when debugging, we often, when we're doing well architecture with teams, we do see that teams who are generating logs maybe only look at them when they're trying to solve a problem, and that's not helpful either. So do have a think about those detective controls if any of these apply to you. So the next area is infrastructure protection, and these are architectural patterns and products to keep things safe, basically, to kind of the last set, the detective controls, was about noticing things when they're going on. This is really about designing protection into that infrastructure. So infrastructure protection, a good sort of first consideration is the VPC design. If you've been using AWS for any appreciable amount of time, you'll have seen a graph, a diagram that looks a lot like this already. The VPC design here presents a public subnet and a couple of private subnets per availability zone, and provides NAT egress for the public subnets. So in this design, it isn't possible to reach the services in the private subnets from the internet unless there is also a load balancer or API gateway or some other service in front of them. And traffic leaving the private subnet A here, for example, may be able to egress through NAT gateways in the public subnets, but private subnet B here may not be able to route out at all, right? They may not be able to get any traffic out of that network, which might be where you put your data services, for example, so that you're limiting the likelihood of data repatriation, shall we say. We, in our well-architected reviews, find that teams that haven't done a good job in this area sort of have everything in public subnets. Everything's got a public IP address. There are maybe security groups in use to protect those resources, but really you should be looking at a layout like this if you're running services in a VPC, and particularly if you're running container or EC2 services, you want to be looking at this sort of thing. And again, I think tutorials are to blame for this. I think there's a real problem in that most tutorials or sort of learn this thing stuff on the internet is optimized for the mean time to hello world. So you can very quickly get something up and running. But a lot of people who are writing those tutorials don't also give you a big red box saying, by the way, don't fucking do this in production because it's dumb. And I think there should be a little bit more of that. In fact, I think I've got a blog post in me on this topic. Ultimately, I'd love to see people writing web tutorials with a put a big caveat on things about whether or not this is actually production ready, because a lot of the time it won't be. Sorry, that's my soapbox. I'll get off that for a second. The other thing that you want to be looking at, regardless of how you're running things and what you're running, is security groups. If you're from a traditional infrastructure background, a security group sort of looks a bit like a firewall, or a group in a firewall. It's not quite like that, because these sit in different places. But a security group is a way of expressing how traffic can flow between themselves and other security groups, essentially. So in this example here, we've got a default security group that all of our app servers live in, and maybe that allows administrative access from a Bastion host, or it allows connections from your connections out to your logging infrastructure or something like that. We also here have an app 1 and an app 2 security group. The app 1 security group encloses both the application servers and the databases that they use, which is a reasonably common pattern. And so the security group rules there might say you can send database traffic to other things in this security group, but not to anything else. And application 1 and application 2 may not be able to send traffic to each other at all, or they might, depending on your use case. So if your security groups are not well thought through, that might be an area for review and improvement. We see these done, see these applied sort of in a sort of probably a more permissive way than they probably should be, and maybe not in a sort of consistent manner. So probably worth a review and a rethink if you were learning security groups as you went along. I've seen one client forget that security groups existed at all and just use subnets separately for that. That's not a good idea. The complexity of that is pretty wild. You also need to create a security group with CIDR blocks in if you do that as well. So it's kind of mad. But have a look at your security groups as well. We've covered IAM earlier on. Please remember, teach your teams IAM. Some of the services provided by AWS also have what are called fine-grained policies, and this is again an IAM consideration, and these are policies in IAM that relate very specifically to these services. So KMS, which is the key management service, you can put a very specific policies in IAM policies relating to KMS. So restricting access to specific keys in KMS is one thing. S3 is probably the most common example of, or the most commonly used example of fine-grained policies, which allows you to put access control on specific bucket paths or particular keys. And SNS has some fine-grained policies as well. If you're using any of these services, it's worth going to have a look at the policies that they provide and being kind of critical about whether or not you have a least privileged position on those as well as everywhere else. In all of the service documentation on AWS, there is a section on IAM to cover how you control access to it. It isn't always just the API calls. Sometimes it is these fine-grained policies as well. So worth looking into in that detail. Another architectural pattern that you might want to think about, particularly if you are running on-premises infrastructure still, or you're maybe partway through a migration, or you have some resources that just need to be on-prem for some reason, looking at Direct Connect, which is a way of extending your network into the AWS VPC, essentially. So you'll end up with a physical peering connection between your network and an AWS point of presence. Telehouse in the UK has a couple of those. There are other locations as well. And by doing that, you can pass all of your VPC bound traffic over a network that essentially you control. There are BGP relationships to set up. I've seen Ben Carter on the list. If that's the Ben Carter I used to work with, Ben will be really interested in this stuff. And the BGP stuff is all set up to fail over nicely. You can also create VPN backups for this stuff. And there's also something called Transit Gateway that I haven't got a slide on, which allows you to essentially connect via via your Direct Connect link into a central hub, and route traffic out from that transit gateway out to different VPCs. So if you're in an environment where you have a lot of AWS accounts, and your accounts all have different VPCs in, and you want to connect any of those back to your home network, if you like, Transit Gateway is worth a look. I attended a partner webinar this week on Transit Gateway and the various things that you can do with it. There's some pretty good stuff in there. So do get in touch if you'd like to know a bit more about Transit Gateway, because that information is fresh in my head as of Monday. It is that, Ben. Hi, Ben. Good to see you. Other things to think about enabling as you build your platform, is AWS Shield. So if you're using CloudFront, or you're using API Gateway, or you're using an ALB or an NLB for your load balancing, you get access to Shield by default. And Shield is the DDoS protection service provided by AWS. So if you start getting spanked by huge amounts of malicious traffic from outside of your network, then Shield will do something about that. There is also Shield Pro, which allows you to basically gives you a line in to communicate with AWS about sort of active mitigation, and is a bit more of a nuanced relationship. But I would posit that most people don't need that, as long as you're using things like CloudFront, ALB, and NLB. If you just present your services out of an IP address attached to an ENI that's hanging off an EC2 instance, those are not Shield protected, and so sometimes it is worth adding a CloudFront distribution or a load balancer in front of just a single service or a single server in order to benefit from the Shield protection that gives, rather than having that hanging out on its own on the internet. You might also want to look at the web application firewall. WAF provides layer 7 filtering of HTTP requests. So you can use managed rule sets, or you can create your own rule sets. And those managed rule sets are provided by vendors who themselves used to provide WAF appliances, so you can still benefit from the experience of those vendors if you've worked with a WAF vendor previously. And a lot of these sort of things are things like looking for HTTP requests that look like they might be SQL injection attacks, or known attacks against versions of WordPress and that sort of stuff. And so if you are running a public-facing web service, then WAF is probably worth considering. We don't see a lot of it used in the field. I think a lot of the places that end up using WAF are people that necessarily have to because of their compliance position, or people who've been affected by some kind of attack that would have been mitigated by it. So do have a look if you're not using that. The pricing and everything is as is usual with AWS, based on total number of requests or traffic throughput and so forth. So worth a look. You might also want to look at AWS Inspector. Inspector is a tool for what Amazon call provable security, which is consistent running of baseline checks for security considerations. An inspector is it's going to scan from your hosts. So if you're running EC2 instances, Inspector runs an agent on those hosts, and runs checks from them. And one of the things it's doing is looking to see what the network reachability is like. So if you've got private hosts and they are connecting and you need them to not be connecting outbound to the internet, then you can use Inspector to validate that is still true. Inspector will attempt to make outbound network connections and will report if it finds them. It can also check hosts against known CVEs. So if you're using if you're using an operating system that is supported, Red Hat, CentOS, Ubuntu, so forth, probably Windows as well, of course, then Inspector can examine the list of packages installed and let you know if any of them are vulnerable against known CVEs. You can also use Inspector to check against the CIS benchmarks. So if you're familiar with that, that's configuration hardening for instances. So things like making sure that you can't execute files that have been uploaded into temp directories and so forth. You can continually check those invariants on your host using Inspector. There are a bunch of other security best practices as well. And one thing that I hadn't come across before, it'll also look for applications running that have unsafe runtime behavior. So apps that have been compiled in a way that allows the code to be rewritten. Areas of memory that haven't been adequately protected against rewriting, for example, Inspector will check for those and alert on those as well. So I've never seen anyone using Inspector, I don't think, unless they're people that we've built the platform for. So if you're running EC2 instances, you definitely want to be looking at AWS Inspector, and particularly if you're part of a compliance regime of some sort, you'll probably find that would replace some vendor tooling, and that might be a cost-saving activity for you. Other vendor tools worth considering. There are various tools out there for running in the host or on the container to make sure that you're working securely. ClamAV we've used a reasonable amount for customers who need antivirus on their Linux machines to tick some compliance boxes. We are currently working with Sneak on some of their tooling and working towards partnership with them. So if you're working in the languages that they support, Sneak can check your Git repos for vulnerable dependencies and can scan your containers and so forth as well. There's also Twistlock and Aqua who sort of live in more or less the same space. I think once I've signed the paperwork with Sneak, I should probably take those logos out of my slides. And OSSec, which is a free tooling for scanning security on your operating system. So these would live in various places, so possibly part of your CI pipeline, possibly part of your runtime environment, all worth considering if you are in some kind of compliance regime. This webinar came from an in-person slide deck, so at the point at which I get to this slide in person, I would invite someone from SearchPilot to come and talk to you, but I haven't done that today. But SearchPilot are an optimization delivery network. They transform web traffic. It essentially works as a proxy, transforming web traffic to do multivariate SEO testing, and so they can serve up from your CMS. They can serve up A/B tests on certain content changes from their platform without you having to modify your own application. And as a result of how they work, they transact plain text HTTP requests internally, or at least their code sees plain text HTTP. And as a result of that, and the fact that some of their customers are e-commerce customers, they are privy to plain text credit card details. And so it was a requirement of their platform that we helped build the original version of to implement supports for PCI DSS working at the highest levels, level 1, which is essentially if you're going to see plain text credit cards or handle credit card numbers on your network, then you need to conform to that. And so a lot of the things that I've just talked about really relevant for the PCI DSS landscape. We added WAF. We added some vendor security scanning. We put AV in place. We put in some additional scanning to make sure that the checksums of all the software that they were building for deployment matched their expectations on a sort of consistent basis. And so a lot of those controls, if you're working with PCI DSS, you'll probably want to consider because they're relevant in this landscape. What about serverless? Is a question that I think is probably fairly frequently asked these days, and certainly should be. A lot of the tooling that I've covered there is tooling that runs on EC2 instances or in containers. And actually, if you're not running EC2 instances or containers, such as you might be if you're adopting AWS Lambda, for example, which is a serverless technology, then you don't need any of that stuff, because you're pushing more of that operating system consideration down into the somebody else's problem part of the equation. So if you are using Lambda, you need to make sure that your application dependencies are up to date and secure, but you don't have to worry about certifying an operating system, because Amazon is taking care of that for you. And this is another example of leveraging the platform. If there is a way for you to adopt a serverless approach to what you're doing, and not everything suits it, and certainly not everything suits Lambda as an operating position, then you save yourself some more work. You don't end up doing your monthly patching runs and all the other bullshit that goes on with running operating systems. So do think about serverless if you can, because it will save you a lot of problems. In the AWS landscape, serverless is typically used to describe things like Lambda and S3 and API gateway and things that run without an operating system for you to care about. AWS would also refer to Fargate as a serverless platform. And Fargate is a container runtime environment. And in that universe, you can run containers within an operating landscape that you don't have operating system responsibility for. So as long as your container dependencies are up to date, which is a reasonable ask of a development team, I think, then you are taken care of from a security perspective by adopting Fargate. Fargate on a sort of cost comparison basis is about 8% more expensive than running equivalent EC2 compute, but that 8% covers all of that operating system maintenance and sort of janitorial sysadmin work that really you shouldn't be doing these days in 2020. It shouldn't be necessary. And designing a platform such that it is not necessary is a good idea. So your protection might need some work if you've got anything other than load balancers or NAT in public networks. So don't be running your services in public networks. That's probably not the right answer. If your security groups are too permissive, you probably want to spend some time tuning those up. We can help you with that, of course. If you are mostly referring to CIDR network ranges in your security groups, you probably missed the point of security groups a little bit. So that's a smell. If you go and look at your security groups and you find CIDR blocks in there, and you're not using Direct Connect or other sort of connections back to your home base, then you probably need to rethink those. If you're not using WAF, then maybe that's worth a look. If you're not actively scanning for vulnerabilities, then you probably have some. And if you're not checking the dependencies of your applications and making sure that they are secure, then again, you're likely to have a bad time. I think that the OWASP top 10 list of security causes of security incidents still contains application dependencies every year, right? It's always that. A lot of the high profile stuff over the last couple of years were high profile security incidents over the last couple of years were down to application dependencies, things like Java struts and so forth, not having been updated by I think there was a bank or a building society or something, and there were a couple of things that looked the same, and they were exploited because their application dependencies were out of date. And you need to make it clear that is your application team's responsibilities, and put some service level agreements in there as well. So the next area is data protection, which is all about limiting access to and encrypting your data. One thing we see very rarely is data classification. So teams thinking about identifying different types of data in their infrastructure and classifying it at different levels. So is this sensitive? Is it corporate secrets? Is it personally identifiable? Is it publicly available? Like identifying those pieces of information and making sure that you know to what extent they're sensitive. Tagging of resources to indicate which data services within AWS manage what types of data, also important. You can use KMS keys at each classification level. It's a really good way of protecting data at different levels. So you can use KMS keys in pretty much everything that involves encryption in the AWS landscape. S3 is a good example. You can encrypt things going into S3 using a KMS key. If you were storing personally identifiable or otherwise sensitive data in S3, you can use a KMS key that is made available only to the service that's writing that data and only to the users who have the right level of classification to get at that data. Other users might be able to look in the bucket, but unless they have access to the KMS key, they can't decrypt anything. And that's a really good way of demonstrating, at least to an auditor, that the security is controlled in that manner. Controlling principal access to keys and resources. Guess what? That's IAM again. Do use IAM properly. Do teach your teams how to use IAM. And you can look at tokenization of data as well. There are various services for tokenizing sensitive data as it goes into the database. A lot of those are commercial. I don't think AWS has a solution for that, but that, depending on the type of data you're storing, that might be worth looking at. And if you are storing data in S3, you can consider AWS Macy, which is a machine learning tool which will look for sensitive data in S3. So looking for personally identifiable stuff, credit card details, that sort of thing. This is an area where actually building microservices might make life easier rather than harder, and it's unusual to find a use case for that. If you have separate services handling your sensitive data, then you can reason about the nature of the handling of that data very separately from the rest of your application. So it might be worth considering from an application architecture perspective, separating out services that handle your more sensitive data, so that you can reason about them and protect them differently. A note on AWS Macy: it's bloody expensive. You're going to want to run it constantly for the best level of protection, and it's pretty spendy. So do go in eyes open when it comes to cost on those things. At rest, almost all the data storage services have features to encrypt data at rest. They're mostly easy to turn on as well, so there's no real excuse for not encrypting data at rest in things like your object storage, your databases, in your EBS block storage. If you you should also be using IAM here to limit personnel's access to data at rest. So if your team doesn't need to get at a particular type of data, then reducing their access to it is a sensible thing to do. The thing to bear in mind if you are using EC2 instances and you are writing data that might be sensitive to the root volume, which is not the best approach, but it's good to cover this as a belt and braces thing anyway. If you're using a base AMI provided by another account, you can copy those into your account using KMS encryption, and then using that AMI will boot EC2 instances in your VPC using that encrypted volume. You have to copy it in because they're going to use your encryption keys. But this is easy to do in Terraform. As an example, you can quite easily create an AMI as an encrypted copy of another, and it's worth doing if you need everything to be encrypted at rest, and you can point your auditors at it and they'll put a nice tick in that box for you. One thing to bear in mind, of course, if you're I guess I might have a slide on this later, I'm not sure, but if you're backing your data up and storing those backups somewhere like S3 buckets, please make sure that your access control for your users matches between backup and original source. Like, there's no point having access control around your sensitive data that limits specific personnel from getting access to those secrets if you're going to make the backups available to your entire team. That's just dumb. Secret protection is an area of consideration. We see very bad adoption of this, really. This is kind of, again, teams baking passwords into config files or into code. We still see this a lot. There are ways of storing those secrets in AWS services so that you're not keeping those plain text anywhere. So AWS Secrets Manager is a good example of that, where you can poke structured JSON data into Secrets Manager. That will be encrypted, and then you can use IAM policies to determine who can get at those secrets. And again, in combination with instance profiles, then you can allow specific services to get at the specific secrets that they need from Secrets Manager as they start, without you having to bake those into config files. So do think about using Secrets Manager if you're currently holding API keys for external services or whatever in config for your code. You can also generate temporary RDS tokens. So if you're using RDS databases, you can have the RDS system generate a set of credentials that are, I think, 15 minutes long or something for some of your services to use. There are some caveats around that. It's best to use those for batch processing or administrative functions. It's great for allowing developers access to databases on a temporary basis. It's not great for highly transactional systems because the service doesn't guarantee availability sufficient for that. Parameter store is another place that can store encrypted secret data and other parameters. And so it's sometimes difficult to tell whether you should use Secrets Manager or Parameter Store. I don't think I'm clear on which of those two is the right solution, but Parameter Store is sort of thought of as a more general purpose config store for applications. Again, here's some IAM. Make sure you're controlling access to those secrets for your principals. And do consider that there are vendor solutions for secrets protection as well, where the AWS solutions don't quite do everything. HashiCorp Vault is probably the main contender in that space. Worth a look if you need to manage X509 certificates or other things that Secrets Manager or the AWS tooling doesn't really do very well natively. But for the most part, you don't need Vault. Like typically, you can do everything you need with Secrets Manager, Parameter Store, and so forth. Protecting data in transit is also an important consideration. So using HTTPS where it's available. All the load balancer solutions have HTTPS listeners. HTTPS is available in CloudFront. You can generate certificates and use those using the AWS Certificate Manager, and you should be doing that if you're using certificates with the AWS services, because it makes renewal and so forth much easier. And of course, using VPNs for your client users where necessary is I think you can do as well. I put a star there because actually we found in many cases that VPNs are not necessary these days. We've got a couple of patterns for exposing internal web interfaces to external users with authentication via an OAuth source, using things like CloudFront and Lambda Edge and ALBs. So in one of our compliance-oriented customers, we actually exposed their ELK dashboards and their other monitoring dashboards to the internet, but protect access to them using HTTPS and using authentication that is managed by CloudFront and ALB. So if you're VPNs are really troublesome for some users or some types of users, and if you have users who are constantly on your help desk saying, "I can't get the thing," have you turned your VPN on? No. Then you probably benefit from looking at those solutions as well. Paul is asking, are you able to share your slides? Yes, absolutely. You will get an email when we're done today with a copy of the slides and a link to the video recording as well. Thanks for the question, Paul. Backups. Yeah, we mentioned backups. Almost every service has a backup feature of some sort if it stores data. There is a central backups management service that you can look at, which keeps all this stuff in one place. I think that works across account as well. You can also, in some cases, replicate data into other regions. So if your failure considerations are that you might lose an entire region, probably unlikely, but maybe from a compliance position, you might need to demonstrate that you're protecting against that. You can replicate data from one region into another. Data does not leave a region unless it is configured to do so. So from a compliance perspective, if you've got something in Ireland, you can guarantee that that data is not leaving Ireland unless you've made configuration changes to make that happen. But you might want to make configuration changes to make that happen in order to ship backups over. There are some key management implications. So if you've got backups encrypted with KMS keys in one region, you need to make sure those keys are available in another region if you need to access those backups in that other region. We've done a lot of thinking and work in this area. So if you're thinking about that sort of backup solution, then do get in touch. We can probably help with that. So your data protection might need some work. If you've got too many people with too much access to too much data, that's an IAM problem. Teach your teams IAM. If you haven't thought about data classification, and most teams haven't, you should at least just go and write down what data you've got and in which tables. Even if you're not separating those out to other services, it's worth thinking about at least. If you're not encrypting at rest and in transit, then you should be turning those on probably. If you've got secrets stored anywhere other than in AWS or vendor services, then you can definitely improve that position. And if you don't have complete backups, then you probably need to do some work there as well. And if you haven't tried restoring them, you don't know whether those backups work. Your backups are only as good as the last restore you made of them. So do make sure you've got rehearsals of your incident processes in there. And so we'll look at incident response, which is, what do you do when things go wrong? You can automate responses to some activities. So if you've got CloudWatch well configured, then it can trigger events if certain things happen, and you can use CloudWatch events then to send notifications or trigger actions in Lambda and so forth. So automated remediation is always a good bet. If you can predict for particular failure cases, you can probably automate some of the remediation of them, and that's worth doing. One thing that teams don't really think about in our experience is the sort of clean room configuration. So in the event of, for example, an EC2 instance getting owned by a third party, then you want to be able to do something with that instance to understand what happened, and really you want to examine that in a clean room environment. So the good practice recommendation from Amazon here is to provide a mechanism by which you can trigger an EC2 instance to be quarantined, that is moved into a different subnet or into a different security group, so that it can't transmit or receive traffic, but it can be accessed by your team, and generally sort of shut down and snapshotted and other sort of other bits and pieces. If you don't have forensic tools installed on all your EC2 instances, then by the time you've got something in your clean room, it's too late. You don't want to expose that instance to the internet to install those forensic tools. So having them on there as part of your base operating system build is a good idea. Making sure that you've got your security team or security individuals have shell access that they can get out without there needing to be any kind of external connection to an LDAP directory or whatever, so that those examinations can happen in a clean room environment as well. And as I've said, automatically quarantining those nodes when they become suspect, it's a good way to handle that. So doing that sort of preparatory work is pretty straightforward. Knowing what to do in the event of an incident is less straightforward, but being prepared is part of the game, really. Similarly, on the topic of preparedness, run books and playbooks, we see these are pretty absent. We don't see teams writing down details about how they will respond to particular types of incidents. They don't do that thinking up front. And that's one of the areas we can help with. We can help you sort of design an incident response for security incidents and also for sort of more general operational considerations, and help you write those run books and playbooks, because they're almost never in existence, we find, when we've had reviews with teams. Making sure you've got team members who are on call. This is a maturity thing, I think. Younger teams either rely on everyone just being available, maybe if something happens. More mature, less prepared teams have people shirking the responsibilities of running the code they've written. So do build on-call rotas and involve your developers in that. You should be running regular drills as well, and sort of making sure that your response approaches have been tested and are likely to work in the instance that you need them to be. to be working. So your incident response might need work if you can't remediate common incidents automatically. If you don't have a way of quarantining bad news for forensics, then that might need some change as well. If your engineers are not on call for security incidents, or in fact any incidents, then you probably need to work on that. Engineers who don't know how to respond to on-call alerts are a problem, so make sure that everyone is adequately trained and has access to documentation. And if you're not practicing incident response, whether that's security incident or more general, then when an incident happens, you're going to be screwed. Basically, you're going to be relying on luck and good judgment. And if you haven't practiced the approach, then that is all you have to fall back on, and the incident will likely last longer and have more impact in that scenario. So we're coming towards the end. I've given you a lot to think about, and I'm very aware that there's a lot here, and it's a complex and deep topic. One thing to sort of bear in mind, if this seems too much, and there's a lot of things to have opinions about, is AWS landing zone. So this is a little less relevant than it was when I wrote the slides originally, but landing zone is a set of AWS opinions about multiple account layout, security configuration, logging configuration, and so forth. So you shouldn't need to spend time inventing these yourselves. Something like landing zone can provide this. Landing zone is a sort of janky collection of cloud formation that was provided by AWS solutions architects over the years. We've deployed it for a couple of clients, and it's sort of useful for them. Here you can see there's a sort of multiple account layout with AWS organizations at the top and some shared services provided by shared service accounts and a log archive account and a security account. Then landing zone also provides opinions about which detective controls to enable. So things like logging and aggregation of security notifications, CloudTrail, AWS config, which I didn't mention actually, which is a way of checking your system for checking your AWS accounts to make sure that certain rules have been followed. So firing an alert if somebody attaches a public IP address to a private system, for example. Landing zone also then has opinions about how identity is managed, so through AWS's own SSO endpoints, and they provide baselines for new accounts to sort of set up all the security stuff in there and the connections back to the shared services account. So you can use landing zone to create this multi-account layout with all of these security controls already enabled. And we did that for Essentia Analytics, who are a customer we've been working with for, I think, probably almost 2 years at this point. And they're in a highly regulated industry that they work with hedge funds and work with hedge fund data, and so it's really important to them to have the security stuff taken care of out of the box. I can tell you more about that. We're in the process of writing up that work as a client case study on our website, so you'll be able to find that shortly. But actually, it seems like landing zone is also quite a lot to think about, and it is. And so AWS have provided a service called Control Tower, which is generally available, and that also has strong opinions about multiple account layout, single sign-on, centralized logging, security audits, and so forth. And so Control Tower allows you to set up all those logging and audit accounts yourself. It allows you to create account baselines for new accounts to join that landing zone, as they call it, and allows you to tie all that together with AWS Service Catalog so that you can allow your teams to self-service vend new accounts with your security opinions baked into them, without you having to get involved. So that's really worth looking at if you're going to be in a multi-account environment, particularly if you're a bigger organization, but we're actually deploying this for some smaller businesses now as well. And this sort of ties together that multi-account deployment story really neatly. So definitely worth a look there. So what's next? That's all of the sort of technical material. If you are at all interested in working with the Scale Factory, we can help you with some consultancy stuff. We do training on a lot of these topics. We can do a well-architected review for you to give you a sense of how your security practice is, as well as your cost management and your operations and your reliability and stuff as well. So do consider that. And if you're not yet in AWS, we can help with a migration story. As a partner with AWS, we have access to a number of funding funding pots, some of which are pretty hefty, particularly where they relate to getting new workloads on AWS. So if you're thinking about a migration or a new platform build, there is almost always some kind of funding we can access in exchange for working with us on that project, of course. So do think about that. Well architected. I'll send a link to this in the email. You can book a review online, and typically takes about 4 hours. There are 60 questions. We cover all those areas, and there's funding available for making changes. If you are a CTO or a VP engineering, or you're otherwise involved in technical decision making, I run a monthly session called Breakfast Ops, which is it was originally an in-person discussion with bacon rolls in my office. At the moment, it is fully on Zoom. I typically choose a topic or two every 4 weeks, and we just sort of join and chat between peers about those topics. We've covered security. Actually, 2 weeks ago, we did security and compliance, so I'm afraid you've missed that one. But we regularly cover topics that are likely to be of interest to you. So if you'd like to join Breakfast Ops, please let me know, and I will add you to that list. I'm happy to take further questions. I know there were some during the session. We are kind of bang on the 90 minutes that I thought this would take, but I'm good for a few more if anybody has anything burning that they'd like to ask, which I will stick around for a minute or so and see whether anyone has any questions. If you don't have questions, thanks for joining. I will be sharing the video and the slides, and that will be from my own email address. So if you have any questions that you'd like to ask that I didn't answer today, or you'd like to set up a conversation with one of my solutions architects for a bit more of a sort of deeper dive chat about some of this stuff, then please do just reply to the email, and I'll hook you up with whatever you need. Okay, no questions so far. And people leaving. All right. Thanks very much, everyone. It's a pleasure to present for you. Be safe. We'll speak soon.